Hi everyone, and welcome back to the channel. Over the next few days, we're diving deep into AWS security, so make sure you subscribe and hit the bell so you don't miss out. I've created a playlist for these videos, which you can find linked below, and we'll also be doing live streams where we can study and check out some memes. Today's focus is designing secure access to AWS resources. Protecting our data from unauthorized access is paramount, and we'll be exploring how to achieve this using key AWS services like IAM, Identity Center, STS, and SCPs, which is Service Control Policies. We'll be keeping the security pillar of the AWS well-architected framework in mind throughout this discussion, ensuring our solutions are robust and resilient. Let's get started with the shared responsibility model. Before we dive into the specifics, let's clarify who is responsible for what. The AWS Shared Responsibility Model outlines this division of responsibilities. Whether we're using ES like EC2, PaaS like Elastic Beanstalk, or SaaS like Amazon QuickSight, certain responsibilities always fall on us, including customer data protection and client-side encryption. For instance, with EC2, we manage the OS and security configurations. With Lambda, AWS handles more, but we still manage permissions and access control. A core security principle is least privilege, granting users and services only the necessary permissions. We often implement this using a multi-account strategy, separating environments like production, staging, and development to isolate workflows and enforce specific security boundaries. This limits the blast radius of any potential security breach. Managing multiple accounts can be complex, but AWS Control Tower simplifies this. It sets up a multi-account environment with pre-configured security guardrails and allows us to customize these guardrails through policies and landing zones. This ensures consistent security and compliance across all accounts, which is especially useful when we have organizational units or OUs. Service Control Policies, or SCPs, act as organizational guardrails, defining what actions can or cannot be performed in member accounts. They do not grant permissions themselves, but rather constrain what actions can be taken even by administrators. For example, this SCP prevents any IAM user from launching EC2 instances in the US West 1 region, effectively limiting our exposure. IAM, or Identity and Access Management, is our core service for fine-grained access control. We create IAM users for individuals, IAM groups to manage permissions for teams, and IAM roles for temporary access or access for services. IAM policies define the permissions granted. A flexible authorization model utilizes users, groups, and roles strategically. We might create groups based on job function, such as developers, administrators, etc., and then assign policies to those groups. Roles can be used for cross-account access or for granting temporary access to external parties. Roles are fundamental to role-based access control. Let's say that we want to allow our development account to access resources in our production account. We can create a role in the production account and grant access to that role. Then, in our development account, we can create a policy allowing users to assume that role. This allows secure cross-account access without sharing long-term credentials. Multi-factor authentication, or MFA, adds an extra layer of security requiring a second authentication factor like a phone number or hardware token. Identity Center used to be called Single Sign-On, or SSO. This service integrates with existing identity providers, sometimes referred to as federated access, like Okta, Azure Active Directory, or Google Workspace. This allows users to log in with their existing credentials, streamlining access management and leveraging your existing identity infrastructure. You can also directly federate a directory service like Active Directory with IAM roles, providing a similar functionality. This is particularly useful for larger organizations with existing directory services. AWS Security Token, or STS, uses temporary credentials, perfect for short-term access. For example, if a third-party vendor needs temporary access to an S3 bucket, we can use STS to generate temporary credentials that expire automatically. Resource policies are attached directly to resources, like S3 buckets. This policy allows a specific IAM user to read objects from this bucket. Lastly, AWS resources reside in specific regions and availability zones. We can further enhance security by restricting access to specific regions, limiting the potential impact of a security incident. For example, you could use SCPs to prevent users from creating resources in regions outside of your operational area. We covered a lot today. We discussed the shared responsibility model, the principle of least privilege, multi-account strategies, control tower, SCPs, IAM, MFA, identity center, STS, resource policies, and the security implications of AWS global infrastructure. In the next video, we'll dive deeper into designing secure workloads and applications. If you have any questions, comments, or complaints, leave them in the comments below. Thanks for watching.